In this video, we are going to look at absolute value inequalities, and our first question is modulus for x minus 5 modulus less than or equal to 7. So if you have got such a question, we need to understand that when the number is in modulus, it has got two values, which is negative part and positive part. So I mean this are going to have open brackets for x minus 5 less than or equal to 7, or is having a negative, or it can be 4x minus 5 less than or equal to 7. So in this case, when you divide this negative, it will go to the other side. So we're going to divide the negative this side, and you can divide the negative this side. So upon division, this symbol, which is less than or equal to, would turn to be like that. Then we are going to remain negative into negative, it's positive. So this side we are going to remain with it 4x minus 5 less it now becomes less than or equal to negative 7, whilst on the other side it is still the same. So you can see that 4x minus 5 is less than or equal to negative 7. Again, 4x minus 5 is greater than or equal to 7. Okay, so in this case, we are saying this number is in the middle, and then it is greater than or equal to 7. So meaning 7 is less than this number. But this same number, 4x minus 5, here it is less. So it is going to be less. So in that way. So this is what I'm talking about. We had the modulus 4x minus 5 modulus greater than or equal to 7. That was the case. We separated it because the modulus has got two values, which is a negative part and the positive part. So the positive part, we maintain everything the way it is. Then for the negative part, we introduce the negative there. Then we divide on both sides with that negative. So here we eliminate the negative, we remain in the positive. But upon division with a negative, this symbol changes to the other side. It changes, turns to the other side, and then this number obtains a negative. So this is where we are. Then we have seen that this 4x minus 5, it is less than or equal to negative 7, meaning negative 7 is bigger than it. Then this side, it is the one which is bigger than 7, so it will be in that case. So when we reach this case now, this is where we solve this value simultaneously, considering going this side and that side. So here we go. We have the negative 5. So we're going to have 4x less than or equal to negative 7. Then here we have got a 7 already. This is a negative 5, which is here. Let's observe. This is a negative 5. It will go this side and it will go this side at the same time. So when it goes this side, it is forming a positive because it was negative. Same case, it will form positive. From there, this forms a 12 less than or equal to 4x. This side, it forms a negative 2 because 7 is the bigger number and it is having negative. So we get the sign of a negative. We get the sign of a bigger number, which is negative, and then we say small number from a big number, which is a 2. Then we can observe we were looking for x, so we divide everything or throughout by 4. So 4 into 4, again 4 into, then this side 4 into. So everything, we are on this level. Now we have reached whereby we have divided by the coefficient of the variable. So 4 into 12, it's a 3, less than or equal to 4 into 4 is 1. 1 times x, we get x. Then we are having negative 0.5, or just half. So this is where we are. So it's a situation whereby on the number line, we can say we have a 3 and we have got sorry, we have a 3, it has to go this side, and then negative 0.5. We have seen that there are these dashes down, so these they mean inclusive. So when you make a circle, you even shade, and then again when you make a circle, you even shade. Then this is where x lies. So x is a value from negative 0.5 to 3. So this is where x is. It's starting from negative 0.5 and it is up to negative 3. So that is how we can represent this on the number line. Okay, thank you very much. Let's try to do the next question. The next question, it's 2 modulus 2x minus 1 modulus greater than or equal to 10. So this is our second question. So solving this question, okay, let me just rewrite it here. So we are going to isolate the modulus. Remember in one of the videos I said let's isolate this. So we are going to isolate it in this form by dividing by this coefficient throughout. So remember, this symbol cannot turn after dividing unless we are dividing a negative number. That's when this one can turn. So it will maintain in the next step. This and this goes. 2 into 10, it's a 5. At this point, we have isolated the modulus. So now we can say it has got two values, which is the negative part and the positive part. So it has got the negative part and it has got the positive part. So the negative part, we will divide by a negative which is there. We'll divide on this side and we'll divide on this side. The positive, it's okay, we'll maintain it like that. Then for the negative, negative into negative, it will be positive. So we'll remain with this guy. But this symbol will turn now after dividing by a negative. So it's the same situation like the previous question, whereby the same number, 2x minus 1, you can see here that it is less than negative 5. So it is less than negative 5. And in this case, it is the one which is bigger than a 5. So it is bigger. So when the number is bigger than the other, the symbol opens towards it. Then if the number is less, the symbol will open against it. That is the thing you can use. Okay, then let's solve simultaneously. So we are looking for x, remember. So we're going to have 2x will remain. Then this negative 1 will go the other side, it will form a positive. Again, this negative 1 will go the other side, it will form a positive. At this point, we can solve this side to come up with a negative 4. Then here we maintain a 2x. Then the other side, we are coming up with a 6. Our aim is to solve for x. So we'll divide all the sides, this part, and this part by 2, so that we remain with x. So after division here, we are getting negative 2, which is greater than or equal to. After dividing, we're getting 1 times x, we are remaining with x. This side, 2 into 6, we are getting a 3. So this is our value there. Then we have to represent this on a number line. So on the number line, we have got a negative value, negative 2. Then we have got positive 3. Of course, numbers keep on going, so we use arrows to show that the numbers keep on going. Then we have got these symbols which are down, apart from having the greater than. So these mean we have to include the value which we have ended on. So that is inclusive. So we are shading so that we know that even this value is part of the values of x. Then the x starts from one end up to the other end. So it starts from -2 up to 3. That is where our x lies. Thank you very much for reaching up to this far. I'm so much grateful. See me in the next video where we are going to look at probability questions. So we'll look at now probability questions.